some preview saying we're going to talk about it, about how you can use deep twin to write complete contracts. That's exactly the purpose for this lecture. Okay, I'll actually post the code that I'm going to show in the slides for you to actually play with. Okay, it's not very difficult, although I say it's tough. Okay, so this slide is general about how you're supposed to write complete contracts. Okay, so let's say, remember the case where when we talk about the account class, remember, let's say in the account class, so we have balance, integer, and we have credits, type integer, and then remember when we say withdraw, and somewhere in the insure clause here, we actually show the case where we simply say balance is equal to, let's say, O balance minus A. Let's say A is the amount you want to withdraw. We actually said before that this post condition here is too weak or too tolerant, in the sense that if somehow your supplier also modifies the credits, which they shouldn't have, but if they have, there's no way for this post condition to capture that, right? Because this post condition here concerns only about the balance attributes, but not the credits. So whatever you do to the credits from the sequence here will not be caught. So in other words, this post condition here is not complete or incomplete. Okay, so that's why I said here for contracts to be complete, you have to say for each attribute, you have to capture the relationship between the pre-state value and the post-state value using the old location, right? So that's why I said the post condition is the only contract that you can use the old expression to say, how do I actually connect the values for this particular attribute? How do I connect the attribute before and after? Okay? So keep that in mind. So whenever you want to, let's say when you do your test, exam, project, whatever, so if you want to make sure your contract is complete, go over all the attributes to see if you address each attribute in your insure clause. If somehow you have, then I think your contract should be reasonably complete. Okay? Okay, however, this is very tricky. Let's say if you attribute, well, in this case, it's very simple. We can simply say credits equals O credits. It's easy. But what if somehow we have some attributes of type, some collection? Let's say we have an array of transactions, let's say for deposits. Remember we have deposit here, which is an array of transaction. Okay, and also we have withdrawals. Okay, an array of transaction. Okay, in this case, if you want to say that we are trying to change, let's say in this case for the withdrawal, we're only going to change the withdrawal attribute here. We are going to keep this untouched, right? And also for the withdrawal feature here, we're going to say we're going to, let's say this is the current withdrawal history. Let's say we have this many withdrawals already in the history. Now we're trying to add one at the end of the list, right? Okay? You gotta say two things to make it complete. First, you gotta say the last transaction here corresponds to the withdrawal you're trying to do. Also, you have to say anything that's before this current one has not been changed. Everything there. That's the tricky part. Because usually when you're changing your collection attributes, you're only modifying one spot. So to make it complete, you're gonna say not only that particular spot has been changed, but also everything else in the collection has remained unchanged. That's how you make it complete. We'll see example, don't worry. Okay, so that's basically what this is to say. So the rule would be for the attributes whose structure is sophisticated, let's say array, linked list, hash table, and then you should specify that after the updates, the intended change is present for that particular spot, and also everything else is unchanged. That's something you're going to say. Okay, now the second one is the trickiest part to specify. I think that you're actually okay with balance equals O balance minus A, or to say, for example, you can say, so here, let's say, you can say something like maybe withdraw. I want to say somehow the last one is equal to whatever transaction you want to create. But then that's only indexing into that particular one. But what about everything else in the withdrawal? You gotta make sure you haven't changed anything there. Okay? So we're actually going to link this. The way we write the second one is going to be related to the deep twin operator in a very interesting way. Okay? So we're going to talk about, because you're going to see that reference copy wouldn't work, twin wouldn't work, only deep twin will work. Okay, we have some usual reference aliasing and iterable structure. I'll show you exactly what I meant. Okay, so now this slide also summarizes what I said last time about how you should think of how the IFO actually checks the pre and post conditions. Okay, so I'm not going to read it literally, but I'm going to show you how you might think of it. So let's say you have a withdrawal feature here. Integer. So I will simply say A larger than 0. Let's say balance greater than 0, for example. Implementation here. So ensure I'll only put balance is equal to O balance minus A. And let's say we also have some variance in the same class. For example, we can say, I'll just make it up. So let's say credits must be positive as well. Okay, so now let's say we're trying to make a call. Account dot withdraw. 10. Okay, so this is before the call. This is after the call, right? And remember, this is the pre-state, and that is the post-state. So right before we call this withdraw feature here, there's several things we have to do. So over there, okay, first of all, we have to make sure right before this feature is executed, the invariance is satisfied. So we want to make sure the current credits is positive. Second thing, we gotta make sure each precondition here is also satisfied. Okay, those should be easy to understand. Okay, now, as for the post condition, we do not have to evaluate the whole post condition yet, but we have to cache some values for later evaluation once the feature terminated. What I meant was, what the compiler would do is to look through for all the old expression. In this case, when we say balance equals O balance minus A, if you only try to find out what this O balance is after the feature is executed, you'll be too late, because balance has been changed already. What you have to do is to make sure before you execute the body here, you have to cache the value somewhere. That's exactly what the IFO compiler will do. So in this case, we actually have some cache variable here. So I'll just make some convention here. I simply just whenever I see old here, I'll just say old balance. You can see I have an underscore here. So there's a sign. Always have a sign here, assignments, and then balance. Okay, so this is a cache value that's complete. That's actually cached before the execution. So now, after the body is executed, now we're going to check two things. First, we're going to check to see the invariance currently is still maintained. So this credit, if it has been changed, we want to make sure the change has not violated invariance. And then also, we want to evaluate this post condition here. So whenever we see anything that's not old, that means that's a current value, the new value. Whenever we see any old value here, that means that should have been cached already somewhere. This is exactly the point that we should refer to the cache variables. Okay, that's the general principle. I summarized that already in the slide, so you can read it carefully again. Any questions so far? and then we'll go through one detailed example together. Yes?
Invariance checked at before and then.
Both before and after. So you want to make sure the invariance is satisfied before the feature is executed, and also after the feature is finished, the invariance is maintained, so that invariance holds always. Okay, that's good. So have this in mind. We're going to see one example here. So let me see how much. Okay. So now, this is the only background code you have to understand. Very easy to understand. Let's say we have one single class called account. In the account, we redefine that is equal. Okay, so we have two attributes here. We have the owner being a string. We have a balance of type integer, and we have some constructor here to initialize the name to be someone, and also the balance to be 0. Very easy. And also here we have deposit, only one command, only one deposit, which will increment the balance and then have some post condition here. Okay? And then we'll say is equal, we redefine that to say two accounts are the same as long as their owners are the same and the balance are the same, even if they are different account objects. Okay, that's all the background code you have to understand. Anything else? Maybe another slide? Okay, sorry, there's another one. Okay, we have, so that's the supplier of account. So we have account, and now we have the bank class. So we have some constructor here. So we can, so the attributes that we're going to focus on is the accounts of type array of account. So that means one single bank has an array of account objects. Okay, so that means I'm going to erase this because I'm going to need a whole board to explain. So one possibility is, let's say, so now let's say we have some bank of B. So this is some bank objects. And that has only one attribute there, which is called accounts. And this is basically an array of accounts. Okay, indices start with 1. Let me just put 2 accounts there. Let's say the first account, it could be, and each account class has the owner and also the balance. Okay, so now let me just put. Okay, so owner, I'll just put owner here and balance here. So let's say initially, let's say 0, and then the owner here is a string objects. Let's say the owner is, let's say, Jeremy. Okay, that's the second account object here. So again, we have a similar structure here. So that's the owner and balance. Initially, let's say that's also 0, and Jeremy, let's say Andrew. I think 2 accounts would be sufficient. Okay, that's basically the structure. Any questions so far? Okay, and we also have some commands for us to initialize the bank with some empty array, and we also have to actually have a way to see what's the account of some name. For example, if we say account of Jeremy, that should return back to us this account objects. Okay, I didn't do the interpretation because that's kind of irrelevant to the demo. And also we have the add command, which will add a single account, a new account with the name, provided that the account owner is not there. So you are supposed to actually understand the preconditions I put over there yourself using the cross notations. So those are exercises for you to understand. Okay? Also, when I give you the starter code, you also see those codes in the projects. Okay, so here we're trying to add a new account and then put that into the end of array using the force feature. Okay, so far that's the about the account and also the bank. And this is a typical layout for the objects. Okay? So now, this is a roadmap for how we finish the rest of the slides. Okay? Because I realize it could be very confusing if you don't follow this slide, so please pay attention to these slides. We're going to show you in total 5 versions of how we do the post condition. Okay, 5 versions. And the first version, okay, we're going to show you the post condition for this particular feature. So we're going to deposit into, let's say, for Jeremy's account, for, let's say, $2 or $3, etc. For the particular person with this amount, that's the post condition we're trying to write for this particular guy. Because remember, in this case, we certainly have to somehow to modify the accounts array, right? To actually modify that particular account, but also for the contract, for the post condition to be complete, we want to make sure we don't modify Andrew, right? That's very important to make sure. Okay, so we're going to show you different cases. In the first case, we're going to show you the contracts that are actually incomplete. But in this case, we are lucky because the implementation happens to be correct. So nothing is wrong. However, in the second case, we still have the same incomplete contracts. But now in this case, we're not lucky anymore because the implementation is wrong. But there's no warning from the post condition, which is bad. Okay, now in the third one, we keep the same wrong implementation for the rest. And then we want to see which contract or post condition can actually capture the wrong implementation. That's the goal. Okay, again, the first case is incomplete contracts, but the correct implementation. Okay, that's nothing to report. In the second one, we have the incomplete contracts, but we have the wrong implementation because the contract is incomplete. So it will not be able to capture the wrong implementation. And for third and fourth, we are trying to gradually build up the final solution to capture the wrong implementation. In the first trial, we try to use a reference copy. Okay, in the second trial, we try to use some shallow copy. Both of them will fail. Only the last one, which will use a deep copy, will actually work. Okay, that's a roadmap for the rest of the lecture. Okay, so we're going to reuse that diagram. I may have to modify the name a bit. Okay, so now let's say this is the implementation for, let's have a look at the root. It's very easy to see. So this is the correct implementation. There's no bug in it. So we're trying to see the precondition. You're supposed to understand that. I'm not going to go over that. But now the loop, we're saying, because its account is actually an array, so we're going from lower up to upper plus 1, and then incrementing the counter here. And then we'd say, if the owner of the current account we're trying to look at matches the name we're trying to deposit on, then we go ahead and do the deposit on that particular account. Okay? Let's say, for example, if we say deposit on, so here could be 1, that means version 1. So this is the case of correct implementation, but we have incomplete contracts. Okay? So you can see the contracts here. We say, now since you're trying to deposit, only you're trying to deposit on some existing account, so the size of the account array should not change. So I say account should be equal to old accounts account. That should be obvious. And now I also said that after this, the account balance for this particular person should increase its old balance by A, right? So that's what I'm saying here. I say, return to me the account for this particular person here and get his current balance. And also to compare this with his old balance. So you can see here, this is the old expression, the whole thing, old, account of, and the balance. So this expression here would have been cached already before the execution of the feature. So when you are trying to evaluate this post condition here, you can actually use a cache variable. Okay? So far so good? Okay?
I'll say it again, it's confused. The last one, the insured one, confused.
You mean this one?
Yeah.
So we're trying to say, for example, let's say, actually, let me look at the test. That might be easier. Let's have a look at the test.
Yeah.
So now let's say this is a test case. So we're trying to say create an account, let's create a simple bank, empty bank. add the account for Bill, add the account for Steve, and now, so let me modify this a little. Because we're actually trying to do Bill first, so this will be Bill, so this will be Steve. Bill. Okay, go to Steve here. The reason that Steve, oh, sorry. The reason that the Steve occurs after Bill is because we are trying to create Bill, Steve after Bill. Okay? So now we say deposit on Steve $100. Okay? So you can see that in the correct implementation, it is actually going to deposit. Let's see. That's the test case. We're going to deposit Steve. Okay, good. So we're going to somehow the correct implementation is going to the account for Steve and then deposit $100 and put 100 into it, right? That's what you're going to do. The correct implementation will do. And if you go back to the post condition here, it is to say if you try to get a balance for Steve for the current states, the post states, that should be equal to the value that you get his balance before the execution of the feature, plus whatever amount you're trying to deposit. In this case, the new balance for Steve would be 100, and the old one would be 0 plus because of deposit on 100. Okay, so that post condition will be true. Agree so far? This test case will pass because we got a correct implementation, although the contract here is incomplete because it only worries about how Steve's account has been changed, but without worrying about the others. Let's say Bill. Maybe somehow the wrong implementation actually gave Bill $1 million. Yeah, I think Bill is richer, right? It's Steve. Anyway, so you can see that how this can be incomplete, right? So now, this is the first version here, and that's the test. We're going to use exactly the same test for all the other versions. So you can see after we deposit Steve into Steve $100, we're going to get Bill's balance should remain unchanged, and the balance should be for Steve should be 100. So this test case will pass. Okay, so we get a green bar. That's fine. You can try that yourself as well. Now, second version will be fun. Second version is we got exactly the same contract as before, still incomplete, but now we got the same loop as before, which is correct. Here, the loop here, which is correct, but you can see that after the loop is highlighted as red, we are also going to somehow deposit to the first account the same amount. Somehow. Because it's secret. So that means the wrong implementation here would not only that you want to change Steve's balance from 0 to 100, also change it from Bill to 0 to 100. That's apparently wrong. However, yeah.
So why this is wrong? Account lower R1 deposit.
Where?
Why the red code is wrong?
Because you're only supposed to deposit on that particular person. But you might also, but now here you deposit on another person. In this case, we're trying to deposit on Steve, but you also modify Bill's account.
How to see? But this is only a lower.
So lower means but in this particular test case, because Bill is actually in the lower part of the array.
So it means you only change the build, you didn't change the steel, but
no,
you're
change
supposed.
both.
Why you change both?
Because in this same loop here, we correctly changed Steve's balance, and now we also changed the Bill's balance as well. Okay, that's why it's wrong. You did more than you were supposed to do. Okay, and we can be, and somehow if you run a test case, it will be very obvious because this post condition here only worries about if Steve's account has gone from 0 to 100, but it doesn't care about Bill. So this here will pass the post condition here. However, now we can see that this test case will fail because bill.balance here would be 100 rather than just 0, right? So now we can see that what we get is, rather than post-condition violation, what we get is some check assertion violation, okay? Which means we are getting some unexpected result, but this unexpected result should have been caught by the post-condition of this deposit on feature. So, as I said, this is incomplete. Okay, so far so good?
No.
No? Okay, where?
Still in that part, I still a little bit confused.
Where?
Why the fail is not the post condition?
Because here you only worry about that Steve's balance is equal to his old balance plus 8, which is true.
Oh.
But you don't care about Bill's balance because you say nothing about the rest of the account, right?
And the red line updates Bill's balance?
Exactly. In this particular test case, yes, because you can see that because we put Bill first, so he will be in the lower part of the array. And then we put Steve the second, so Steve will be here. Right? Okay, good? So I think that the other three will be rather quick. Okay, we will actually see the trick. Okay, so let me see, life can have 10 minutes, that should be sufficient. Okay, now, so this also failed, okay, because you didn't fail the correct post condition. So now, this is the third version. We're trying to make it complete by considering the rest of the account array. So in this case, the same wrong implementation, so this part is really the same, okay, the same wrong implementation. But now here, we're trying to say here, what I'm trying to say here? I say across the O value of the accounts, check the following. So this is a universal qualification. If the owner of the current item I'm looking at is not Steve, that means his balance here should be the same as his balance before. Right? Okay, you can see that cursor the item here is actually from the old accounts. Okay, so cursor the item here is really the old value for example, for Bill's account. And now the account of Bill will be returning his new balance. So we want to say they are the same. Okay, let me say that again. So this across here basically says, go across the old value for the accounts and check the following. If the current owner we are looking at is indeed Steve, then that's okay, we don't care. However, we do care about the accounts where the owner is not Steve. For example, let's say Bill. In that case, we want to make sure the old balance for that will be equal to the new balance of that. So that means we would think if somehow the wrong implementation changes from this to that, the post condition here should be able to capture that. That's what we think. Right? Any questions so far? Okay?
So this is correct implementation, right?
No, there's a wrong implementation.
Oh, it means the right one, they change the bills.
No, the implementation, we are now considering the same wrong implementation, but we are trying to make the contract complete. But now the question would be, would this contract here, which seems to be complete, capture the wrong implementation? Think about this. Okay, I'll tell you the result first. So exactly the same test as before, the same test. It actually failed. You can see we actually get the same check assertion violation. We didn't get a post-condition violation. We would expect to get this post-condition violated from the implementation. Okay, so now you need something to draw in the diagram. Okay, here comes the critical bits. Remember how I said the old expression will be cached, right? So the fact that we actually have an old account here, that means before the deposit on version 3 is executed, we have to cache the value for old accounts, right? The way to do that is by simply saying we have some variable here, old underscore accounts is assigned to, that would be accounts, right? That's exactly the expression there. So that's the cache variable we will have before the feature is executed. After that, we actually, to evaluate this post condition here, we use this cache variable. Okay, now, how does this caching process here relate to this diagram? What that means, so you can see apparently this is a reference copy, right? So what we will do is to have this O accounts here points to the same accounts. Agree? That's a reference copy. Yes.
So we're supposed to use the deep copy, right?
No, now we are still using the just O accounts, so there's no copy yet. Yeah. So you can see the expression here is simply old accounts, right? So now that's why we actually see the account on the right-hand side of the caching. So we're only creating a reference that points to exactly the same object as before.
So for your comparison, when you say cursor.item instead of the reference.
Yeah, so I'm trying to say object quality. I'm trying to say the account who's not Steve would be equal to the account who's not, that it would be to his O account.
Oh, so cursor.item.order is not old?
That was, okay, so you can see cursor is actually returned from this old value of account.
So aren't you comparing two old stuff?
I'm trying to compare the old and the new. So I'm trying to iterate through the old one, which also happens to point to the new one. Yeah. So how many of you have followed so far? You know? Or you okay? Okay, let me say it again. I think I only got 5 minutes. I can continue next time. Let me have 5 minutes, okay? 5 minutes, and I'll let you go. So I think I'll try to finish this slide only. So now you can see that since you have this old account expression here, so that means before the feature is executed, it has to cache its value here, the account, using the regular assignment, always use the assignment here. And this will be a cache variable. And the effects of that is going to make a new reference that points to the same accounts objects. Okay, that's a caching process. And now, what this post condition here is saying, so we're saying the old account should refer to this object here, and the current account happens to refer to the same object again. So now we are trying to compare actually the value of Bill from the old value and the new value.
Oh, so because this is the reference copy, so it's just alliance. So this is reference copy, so the post condition will be always true, all right?
It will be always true, yes.
Oh.
Okay. Actually, I think maybe I will spend the first part of lecture next week to cover this. However, one